Yes, okay, recording. Anyways, even though I'm not sure whether it will last around 2 hours or not for the class, but I do have a certain thing that I want to cover for today. And not much. We would say that it's one subtopic, right? Let me share my screen. Okay. Alright, so I believe you can see my screen right now. Let me know if you can't see it. Otherwise, yes, sinus. One of the best thing I've got. Now, curvature. I have prepared some things for me to introduce this topic to you. Okay, so let's begin. This is a new chapter, by the way. Remember that we did a few things on vector calculus, vectors, this and that. We are done. We are done with chapter 2. Okay, so this is chapter 3. Maybe I should emphasize it here. This is not the only thing in chapter 3, but it's one of the things in chapter 3, which is curvature. Chapter 3 is called differential calculus. There's a lot of things inside differential calculus. One of the main things is curvature. And we are going to cover curvature for today. Okay, so to define what a curvature means, a curvature is simply how fast is a curve changing direction. So what does it mean? Okay, imagine there are two curves, just for the sake of an example. One is changing direction very slowly, meaning that it's going down and down and down and down and down, and then it changed direction, going up, going up, going up. It is changing direction, but compare with this, for example, this is changing direction very fast, almost immediately compared to this curve. So you can see that every curve changes direction in a different manner, in a different speed. Even a same curve, even a single curve, not same, but single curve might have a few waves in it. For example, let's say this curve. Okay, so at this part, it is changing quite slowly, and then a very sudden change in direction. And then again, a long time taken to change, and then again, a sudden change, a sudden change. So in one curve, there might be a few points where the curve is changing direction very immediately, and other points where the curve is changing direction very slowly. So rather than drawing this and trying to convince you, I actually found a website just now. Yeah, this. So interactive math something. But the point is this. I want to show you this curve. Okay. The blue color is the curve. Ignore the circle for the moment. The blue color is the curve. Now, how on earth do we even come up with the idea of curvature? How are we going to measure how fast is a curve changing? The idea is that at a point, okay, let's say this point here. Let me bring it here. Okay. At this point, if I want to measure the curvature, my idea is that I'm going to draw a circle that fits the curve perfectly at the point. So at this point, when I construct such a circle, that circle is called the circle of curvature. So you can see when it is changing direction in such a fast manner, the circle is small. But when it is changing direction, when it's taking a long time to change the direction, the circle is big. Okay, so at this point, the circle is big because it's actually taking a long time to change direction. And then immediately the direction is changing. You see the circle is getting smaller. When it takes a long time, the circle is big. When it takes a short time, the circle is small. So there are such things when we measure curvature, the speed of which the curve is changing direction. So from here, you would have seen that if curvature is the speed, the higher the speed is, the smaller the circle is. Okay? And the slower the speed is, meaning that it's taking a long time, the bigger the circle is. So another thing that you can notice from the circle of curvature here is that the line C, this line is called the radius of curvature. Okay, so far we have seen a few terms. The circle is called the circle of curvature. The speed of which it is changing, there's a formula for it, but the speed at which it is changing is called curvature. And the radius of this circle is called the radius of curvature. So today I'm going to show to you, given an equation of a circle, How are you going to determine what is the curvature? How are you going to determine what is the radius? And how are you going to determine the center of this circle? And of course, if you know the center and the radius, you can determine what is the equation of the circle. So everything we are going to learn today is on this circle right here. Okay, and of course, curvature. Okay, so now that I've shown you some kind of diagram here to help you out, let's go to the formulas of curvature. If you ask me, how did we even end up with this formula? There's a long story behind it. I actually tried to check on it, like how on earth did they derive the formula so that I can explain in class. But it turns out that it's not that easy. The way they derive this formula is actually by when you have a curve, just a short story here, when you have a curve and then you construct a circle of curvature, they actually look at the tangent at the circle and then they measure the length of the arc of the curve. They look at the angle here. There's so many things involved in deriving this equation. So I'm going to skip the steps of deriving since we are not learning pure mathematics here. So let's just trust that whoever came up with the formulas here are correct. And you can see that there's no one single formula to determine curvature. There's one, there's two, and there's three. Three formulas to determine curvature. Why? The reason why is because a circle can be described in many ways. The first way to describe a circle is by using the Cartesian form. Or Cartesian form is just another fancy word of saying that we use coordinate x and y to describe the circle. Can you see, for example, they describe the curve, sorry, not the circle, they describe the curve by using x and y. For example, y is equal to x squared. So this is called the Cartesian form. Okay, but this is not the only way. You can also describe, okay, for example, okay, right. You can also describe a curve by using parametric form, meaning that you only use t. You do not use x and y, you use t. The x coordinate you describe in terms of t, the y coordinate you describe in terms of t. Ignore the a here. The a here is just a constant, meaning that it can be 6, it can be 7 and anything. Okay? But parametric means you describe the whole thing by using only t. Okay, last but not least, you have the polar form. We have seen polar form, right? You can describe curve by using r and theta. So there are three ways to describe a curve. And correspondingly, there are three formulas to determine curvature. You see, this is the symbol for curvature, K. Some textbook might even use a little bit fancy K, like I've seen a K with something like this. Yeah. So this is a more commonly used symbol for curvature, but even if you use K, no problem with that. Okay, so that is the symbol for curvature, the formula. As for the radius of curvature, you know what's the nice part is? The nice part of radius of curvature is that this is the formula. Simple. The moment you know what is your curvature, 1 over that curvature is equal to radius. So that would be easy for you because curvature you have to know three formulas, but for radius just take 1 over whatever answer you get for your curvature. Okay, end of story. Alright, so I did tell you just now that I will also teach you how to find the center of the curvature and also the circle of the curvature, but let's leave that behind. It's a whole flow there. If you know curvature, you can find radius of curvature. If you know radius of curvature, you can find center of curvature. If you know center of curvature, you can find equation of the circle of curvature. So it's a whole flow there. Okay, but let's not jump into everything at one time. Let's go slowly into this. And before I start, before I show you how to find the curvature for Cartesian form, do any of you have any questions on what we have just seen? If I see nothing in the chat box, I'm just going to assume that you understand and you are ready to proceed. Okay, so I guess it's fine. So let's go into the first part. So find the curvature and the radius of curvature of the parabola y is equal to x squared. This we don't even have to plot it, right? It's a very commonly known graph. y is equal to x squared is this curve. Oh, sorry, it should touch exactly. Yeah. Okay, even now it's not touching, but fine. Something like this. This is how your y is equal to x squared looks like. So they want you to find the formula or the general form of the curvature. Okay, we know that this is the formula of the curvature. Apparently, we need a y prime and we also need a y double prime. So let's find it. If y is equal to x squared, then y prime is equal to 2x and y double prime is equal to 2. Okay, done. And they ask you the curvature at the origin. Origin means this point right here. Okay, it is 0.00. So let's use the formula shown here. First of all, my curvature is equal to y double prime, the modulus of y double prime. So modulus of 2. Okay. And then 1 plus y prime square. My y prime is 2x. So 2x square. And the whole thing to the power of 3 over 2. So this is just me plugging it in. Let me see if I can simplify it a bit. Modulus of 2 is just 2. 1 plus 2x square is 2 square is 4. X square is x square. So the whole thing to the power of 3 over 2. Okay, so there's nothing much I can do. This is the best I can simplify. So now let's substitute the coordinate 0, 0. Meaning that if there's an x here, put 0. If there's a y here, put 0. So from here, there's no y. So I'm just going to substitute the x. 2 over 1 plus 4 times 0 is 0. Okay. So 1 to the power of 3 over 2 is 1. 2 divided by 1 is 2. So this is my curvature. Yes, Galal, I see that you're doing it as well. Good. So 2 is the curvature. So what was the question asking? The curvature. Okay, done. Next, radius of curvature. Radius of curvature is not that hard. It's just 1 over whatever that you get. So in this case, my 1 over curvature is 1 over 2. So there you go. This is my curvature. This is my radius of curvature. Done. Okay, this is at 0.00. Sometimes they won't ask you exactly at what point. So just give your answer in general. So meaning that your answer might contain some x and y. Okay, but if they ask at a specific point, it means that your final answer will be specific values as well. Okay, this I would say is quite easy actually because it was very short. Not, it won't be always this short actually. Okay, let's go here. Parametric form. So this is one way to describe a curve by using parametric form. You might also see that in some textbook, they will write the parametric form in this way. So the curve is a t minus sine t and a 1 minus cos t. It is possible that they describe it in the form of a vector, but again it's the same meaning. The first component is x, the second component is y. Okay, it's the same meaning anyways. So apparently, according to the formula, I need x prime, I need x double prime. I need y prime, I need y double prime. So let me just find every single thing that I need. Okay, so let's find x prime. Differentiate this. Okay, I'm going to get the a is just a constant. Differentiate t, you get 1. Differentiate sine t, sine differentiate, you get cos. So 1 minus cos t. This is my x prime. My x double prime, okay, the a is just the a. Differentiate 1 is 0. Differentiate cos, you get negative sign. So negative of negative sign is positive sign. Done. Okay, how about y prime? Again, a is just a constant. Differentiate 1, you get 0. Differentiate differentiate cos t, you get negative sign. So negative of negative, positive sign. And finally, y double prime. So a is just a constant. Differentiate sign, you get cos t. So there you have it. We have everything that we need. Okay, I want you guys to try it out. Try to plug in everything that we have here and simplify. What do you get? Try it out on a piece of paper. I will show you the solution in a while. This is not going to be short. So let me remind you that it's not as short as the previous question. So take a full page to answer it maybe. Okay, so by now I think that you would have written down the formula here. So I'm going to scroll up a bit. Dinesh, don't sleep during the class. Are you even trying this? Because if you are trying this, you shouldn't be sleepy. Okay, okay. No, I'm not worrying. I'm just simply saying that. Don't fall asleep. The first line of your curvature is going to be very long once you put in everything. But after that, you got to simplify a bit. Not a bit actually, you got to simplify a lot. It took me a whole page actually. What do you mean by A3 page? No, a standard A4 page. It took me a standard A4 page. So I believe your first line would look something like this. This is just plugging it in, so doing nothing else. But from here onwards, but you might get a rough idea, like you see there's a cos here and there's a cos here. You multiply the two cos, you get cos square t. You multiply these two things, you get sine square t. So there might be a chance to combine the cos square t and the sine square t to be equal to 1. Oh, Sulayam, you already give me an answer, is it? Okay, let me try to write down your answer. Okay, 1 over a square cos t plus a square sine t. Sulayam, this is your final answer, is it? After you simplify everything? Okay. Alright, I did it just now before the class, but I got a different answer. But it would be really hard for me to like identify what is the part that is different from me and yours, because it's a long way around. Okay, here's what I'm going to do. Not only for Sulayam, for everyone, I'm going to take a picture of what I just written and put it in the chat box here. But don't refer to it immediately. If you are done with your answer, then you can cross check to see what went wrong. So just hang there, Sulayam. I'm going to upload my answer now, so you can see which part went different there. And of course, please let me know if you think that you are right and somewhere in my working there's some kind of wrong. Okay, anyways, uploading now. Okay, so there you go. Just uploaded my simplification. It's clear, right? Okay. Anywhere along the lines of the solution that I just uploaded, let me know if you can't understand any of the lines. But it should be basic multiplication, factorization, and so on. Okay, as long as you manage to find out what went wrong, Sulaim, that is completely fine. What happened to the negative? Okay, let me see. If you suddenly ask like that, I have to check which part of the negative. Let me see, let me see. The last, what is it? The last two on the left, okay. Modulus. Oh, you mean here, is it? Okay, here actually what happened was I factorized out a negative 1. Okay, negative a square. That is what happened actually. I factorized out a negative a square. So the thing inside here changes from cos t minus 1 to 1 minus cos t. But since it's a modulus, negative will become positive anyway. So I just remove the negative. So if you want to be really accurate, you can actually put a version with negative here. But in the next step, you can remove the negative because it's a modulus anyways. Is that the part that you're talking about? Okay, all right. So the only thing it disappears is because of the modulus. Otherwise, it would be there. And the reason why I purposely factorize out negative because I wanted to make the numerator and the denominator same so that I can simplify a bit more later on. Okay, so anyways, the rest of you can check it out later if you're still doing it. But at least you get the idea, right? The first substitution will be quite simple, straightforward. But the simplification, you have to be really, really careful. Okay, but of course, please get your derivatives right because the whole thing starts from the derivative. If your derivative is wrong, then your final answer will definitely be wrong. Okay, let's move on to the last form, polar form. I'm not going to ask you to do this because it's going to be another long process, but let me show you that it's more or less the same. Again, you have r and theta here, so it's in polar form, and you have a formula. According to the formula, you need r, you need r prime, and also r double prime. So in this case, your r is a, which is just a constant, 1 plus cos theta. Therefore, r prime is equal to, differentiate 1, you get 0, differentiate cos theta, you get negative sine theta. R double prime is, okay, this can be simplified somewhat to negative a sine theta. R double prime, if you differentiate sine, you get cos, so negative a cos theta. And then from here, just plug in everything into the formula here. And once you have simplified, when you get the final answer, just put your theta to be 0 and then find what is the value. Okay, because we not only want the curvature, we want the curvature at theta is equal to 0. So make sure your final answer you get a value, not an expression, but a value. Okay, it will be a number. Might contain some A. A is fine because they didn't inform what is the value of A. But all the theta will disappear. There won't be any theta or any R inside this. Okay, so not going to spend much time because you can practice later on. Just bear in mind that there are 3 forms of curves, therefore 3 formulas for curvature. And finding radius of curvature is not a big deal because it's just 1 over whatever that you get here. Now let's go to what I would call a combination of everything that we have just learned. We are going to combine radius, we are going to include some other information, and finally find what is the center of the curvature. Okay, so where can I begin? Now, they give you an equation, y square is equal to 2x, okay? And then they ask you to find what is the center of curvature, meaning that if you draw a circle, what is the center at this point? So just to be sure, I actually plotted the graph of y square is equal to 2x. I got something like this. So this is y square over 2x. Okay, so now I know how the shape looks like. So let me just do a rough sketch here. maybe here. Okay, we have something like this. Y square is equal to 2x is somewhere here. Okay, now the point 0.5, -1, let me just estimate. Let's say 0.5 is somewhere here, -1 is somewhere here. So this point, okay, they are asking me if I draw a circle, the circle of curvature at this point. So maybe it will be something like this. I know my drawing is not accurate, but something like that. Okay, okay, this is obviously a bit misleading. Maybe I should draw it. Yeah, it should be following the curve at this point more or less. Okay, nice. Somehow it became an auto circle here. Nice. So this is the circle of curvature. And at this point, right, they're asking me the center of this circle. What is the center point, the coordinate? For the moment, I have no idea. Let me just label it as H and K. I have no idea. But another thing that I know is this line from the center to the edge of the circle, this is the radius of the circle, right? So I know a few information. I already know how to find the radius of curvature. So hopefully, by finding the radius of the curvature, I can somehow utilize the information to find out what is the center of curvature. So is there any information that I have? Okay, maybe I have the points. Let me just write down the point. This is point 0.5 and -1. Okay, so this is the point. Alright, so let me work out the radius of curvature first. In order to find the radius of curvature, I need to find what is the curvature first. So let's find what is the curvature. I have to use the formula here again. Where is it? Yep, this. So I have to use this formula again. In this formula, I need y prime and y double prime. Okay, let me find it. Okay, so y square is equal to 2x. I can push the square to that side so that it becomes plus minus square root 2x. But I feel that it's a bit complicated because I have a plus minus, which is not nice. So instead of doing that, I'm just going to do implicit differentiation. So differentiate both sides, but whenever you differentiate y, you should include a dy over dx. Hope you still remember how to do implicit differentiation. Is equal to differentiate 2x, get 2. Okay, so dy over dx, push the 2y to that side, it will become, cancel off the 2, you get 1 over y. Okay, I don't have to worry about changing the y back into x because I do know what's the value of y here. My y, is -1. So later on, I can just substitute -1. Okay, so let's just leave it in this form then. So if this is my dy over dx, or in other words, my y prime, okay, what is my y double prime? Differentiate y to the power of -1, you will get negative y to the power of -2. Or in other words, this. So I have my y prime, I have my y double prime. I can put it back into the formula of curvature. So the formula of curvature just now, okay, let me put it back. I hope you still have it on a piece of paper. So I will get that the curvature is equal to the modulus of y double prime, which is -1 over y square, over 1 plus y prime square. My y prime is 1 over y, and the whole thing to the power of 3 over 2. Okay, so this is it. Is there anything I can simplify? Yes. I know that modulus of a negative, the negative will just disappear. This part, okay, maybe not much. Maybe I can do this. This thing will become 1 over y square to the power of 3 over 2. Okay, let's just leave it in that form. Anyway, so I was finding the radius at point 0.5, -1. So my y is -1. Let me put that into here. So if I put -1 into here, I'm going to get -1 square is +1. 1 over 1 is just 1. 1 over 1 is just 1. 1 plus 1 is 2. So 2 to the power of 3 over 2. If this is my curvature, then my radius is 1 over this, which is just 2 to the power of 3 over 2. Okay, so that is my radius of curvature. Looking back at the question, was it asking us what is the radius? No, it was asking what is the center. Okay, so at least I know the radius. Okay, this is why I want you to pay extra attention. How on earth are we going to find what is the center? We are going to use a few facts. First of all, I know my radius is this. First step. I know my radius is 2 to the power of 3 over 2. Okay, we know that this is the radius. Is there any formula for us to find the distance between 2 points? There are. Okay, there are a few formulas, and the most commonly known one to find the distance between two formulas is square root x1 minus x2 square. So in this case, h minus 0.5. Let me write it as 1 over 2 plus y1 minus y2 and then square. Minus negative 1 becomes plus 1. This is equal to the distance. But what is this distance? This distance is the radius. So why write d when you know what is the distance? It's 2 to the power of 3 over 2. So we have one formula or one equation containing h and k. You can form another equation containing h and k. Okay, how would you do that? Okay, for a while, guys. I actually spilled something. Okay, done. The next equation you can form. Okay, this one might be a bit tricky, but hear me out. Okay, imagine you draw a tangent line at this point. Okay, imagine that you draw a tangent line. Okay, and you find out what is the gradient of this tangent. Does it sound familiar? The gradient of the tangent line. Do you still remember the gradient of the tangent line is simply y prime? This is the gradient of the tangent line, basic differentiation, right? Okay, so meaning that y prime is my gradient. So what is the gradient of the tangent line at point 0.5 and negative 1? If I put negative 1 into here, okay, first of all, I know that my gradient line, I denote it by m1, is my y prime. I know this. And my y prime is 1 over y. Okay, I know that. So at point 0.5 negative 1, at point 0.5 negative 1, I substitute negative 1 into my y. I get that my gradient is equal to 1 over negative 1 is negative 1. Okay? Keep in mind, for the moment, what I've just did is I found out that m1 is negative 1. Okay, there's another gradient here. What is the gradient of this line, the line of your radius? Is there another formula we can find the gradient line? Yes. Do you remember y2 minus y1 over x2 minus x1? That is the formula to find the gradient. I'm going to use that. Okay, let me denote the gradient of this line by m2. So we have m1, the tangent line, and the m2, the radius line. So in order to find m2, I have to use the basic formula of gradient, y2 minus y1 over x2 minus x1. Okay, my y2 minus y1 just now was k minus negative 1. So minus minus becomes plus. x2 minus x1, h minus 0.5. Okay, so this is my gradient of m2. m1, m2. So why on earth did I find m1 and m2? Because in mathematics, there's a fact that if you have a circle, then the radius and the tangent line are perpendicular. When they are perpendicular, you have a fact saying that when you know that they are perpendicular, 90 degrees, you have a fact saying that the gradient of this line multiplied with the gradient of this line will give you negative 1. You have this fact. So let me use this fact. My m1 was negative 1. My m2 was the whole complicated thing here. And this thing is equal to negative 1. So can we simplify it a bit? Negative 1 and negative 1 cancels off. So k plus 1 over h minus half is equal to 1. Okay. And finally, push the h minus 1 to that side, you get k plus 1 is equal to h minus half. Okay, all this process for what? The whole reason why I did this is to find two equations containing h and k. My first equation, let me put a star. The second equation, two variables, hk, two equations. So what does it mean? It means you can use simultaneous equation. Okay, that's the whole point why I took the effort to come up with these two equations. So I'm going to leave it to you. Try to use these two equations to find out what is the value of h and k. Try it out. What is the coordinate hk? You want to use substitution, you want to use any method, go ahead. But find out what is hk. Or maybe writing it like this is a bit misleading. What is h and k? Oh, what is it, Aiman? Why m1 and m2 is equal to -1? This thing here, Aiman, is a common geometrical fact. It's a common mathematical fact. It says that whenever you have two lines that are perpendicular, the gradient of this line and the gradient of this line, when you multiply, it will be equal to -1. Of course, there's a whole geometrical proof behind it, but right now, just trust me on this. Okay, I will share a link if I find later on. But for the moment, m1 times m2 is equal to -1, only when they are perpendicular, 90 degrees. So for this case, you will always get 90 degrees because tangent line and radius, they always form a 90-degree angle. Lu Jingda, the y double prime, is it? Let me check. Okay. Because you're differentiating in terms of x. I understand what you mean. It means that when you do implicit differentiation, there are two ways to deal with it. One is once you get the form of 1 over y, you should put back your y in terms of x, and then you find your y double prime. Or you can actually leave. Okay, or you can't. Let me see. You can leave because now it's in terms of y. There's no x at all. Okay, you might make sense, Lungjinda. Okay, let me think about it. Are you saying that if I differentiate this, I should put a dy over dx here because I'm differentiating y? Okay, in that case, what happens? Let me see. Let me check. If this is the case, then your y double prime is equal to -1 over y square, and your dy over dx is 1 over y just now. So -1 over y cubed. Is this how you do it, Lujingda? Yes, Aiman, correct. When the angle is equal to 90, m1 times m2 is -1. Anyways, now that you mention it, yes. But I want to know, Lungjida, did you do it this way? Or did you do something else? Or did you add a dy over dx here as well? I see. Let me think about it. Okay, in this case, Fortunately, no matter which version we use, we still get the answer is 2 to the power of 3 over 2. Fortunately, but nevertheless, let me get back to you in this. My goodness, it's basic differentiation and I can't make a conclusion right now. Implicit differentiation. Because I'm just wondering whether at this part, when you differentiate y prime to be y double prime, should you include something here as well? Okay. I'll check back on this. I would have never thought that this would make me blur today. Anyways, fortunately for this case, there's no changes in the radius. Okay, so try to solve this first. Meanwhile, I'll check out the implicit differentiation. And it's official. The official results is the green one is correct. So yes, Lungjida, thank you for reminding us all. Even though we have differentiate this, again we must put a dy over dx because we are differentiating y. I missed out that part. Thank you for reminding me as well. So this should be the correct one. And luckily it doesn't affect the case here. So when it's negative 1 over y cube, maybe the way of writing this will be slightly different because I won't remove the modulus first. I will keep it like modulus of negative over 1 minus y cube. I'll just keep the modulus there. And then over with 1 plus 1 over y squared to the power of 3 over 2. Then I put in negative 1 into here. Right, my y is negative 1, so negative 1 over negative 1, positive 1, and then so the whole upper part will be just positive 1. If I remove the modulus first, it might be different, because when you remove the modulus and you claim that the whole thing is 1 over y cubed, then you put in negative 1, the whole answer will be negative. I swear that I saw something in the chat box, but before I read it, it's already gone. Anyways, did anyone manage to find what is h and k, or is it a very complicated simultaneous equation? Oops, sorry. There's a lot of ways to tackle this actually, but one easy way, not so easy, but at least, right, better than nothing. Some of you might rewrite it. I'm not sure. Some of you might rewrite this. What color should I use? Maybe red. Okay. If you rewrite this first into, for example, k is equal to h minus half minus 1, somewhere it becomes minus 3 over 2, right? Okay. And then you put in this h into the equation. You might have done that, which is fine. You still will get the answer. But I was thinking, why not from here, why not from here just square both sides? If I do that, then I will get k plus 1 square is equal to h minus half square. So this h minus half square, which is the whole thing here, I can simply rewrite it as k plus 1 square. So from this, from there, I will simply get the square root. Okay, the first part becomes k plus 1 square plus k plus 1 square is equal to 2 to the power of 3 over 2. So from here, push the square root to that side. Okay, add these things together, it will become 2k plus 1 square. And push the square root to that side. So this thing when squared, the 2 and 2 cancels off, so you get 2 to the power of 3. Or in other words, 2k plus 1 square is equal to 8. K plus 1 square is equal to 4. K plus 1 is equal to plus minus 2. And finally, your k is either positive 2 minus 1, which is 1, or negative 2 minus 1, which is negative 3. So maybe for me, this feels a bit easier, but it depends. You do how you like it. So there are two k's, 1 and negative 3. Let's look at our sketch. Which makes sense? We have a 1 and negative 3. Negative 3 is somewhere around here. So it doesn't make sense. This is for k. K is the y value. So negative 3 is somewhere around here, down here. So it doesn't make sense, right? Because our our center is up here. It should be a positive value. Okay, but even if you're not sure, let's look at the x coordinate. Let's just be sure. But I definitely don't think it should be negative 3 because this is already negative 1. Negative 3 is somewhere here. Now I'm sure. It won't be negative 3, definitely. So let's ignore the negative 3 and only consider the 1. Okay, so out of the two answers, this cancel. Let's just take this. So if k is equal to 1, okay, you can just put it into any equation. If k is equal to 1, you put it here. 1 plus 1 is 2, h minus half. Push the half there, so h is equal to 5 over 2. So there you have it. Your center of curvature, hk, is 5 over 2 and negative 1. Okay, the rest of you, you might not do it like I did it here, but whatever way you use, just make sure you don't do any careless mistake and you should get h and k as the same coordinate. Although right now, everything is just, hopefully it's correct, right? Because we just did a sketch and then you try to find all this. Unless you plot it exactly, you won't know what is the scenario. So, one last thing. Before I close this subtopic here, if you know the center of the circle, you might realize that you can actually find what is the equation of the circle. Why? Because equation of a circle is this: x minus the x component of the center point square plus y minus the y component of the center point is equal to r square. This is the general form of a circle. So now we know all the information that we want. Our h is 5 over 2. Our k is negative 1. Our radius just now, I forgot what we find for the radius. Okay, our radius is a bit complicated. 2 to the power of 3 over 2. So 2 to the power of 3 over 2 square. The 2 and 2 cancels off. So 2 to the power of 3 is 8. Okay. Alright. So according to all our calculation, my conclusion is this is my circle and this is my center point. How are we going to know whether this is true or not? Let's try to plot it. Let's try to plot the circle here. X minus 5 over 2. X minus 5 over 2 square plus, what was it? Y plus 1 square. Okay. Sorry, is it? Okay, sorry, my K was 1. My goodness, that was a careless mistake. My K was positive 1, not negative 1. Alright. So this is not positive. Okay. Y minus 1 square is equal to 8. Y minus 1 square is equal to 8. So there you go. A circle that fits the curvature nicely at point 0.5, negative 1. So everything that we just did is indeed correct. Okay, so that's how we clarify whether it's correct or not. The circle fits nicely here. It touches the point 0.5, negative 1. So if you know the equation is correct, then you know the center points are correct as well. It's somewhere here. Can't really see what's the point here, but it should be correct. So there you go, an extremely long process, but yeah, hopefully I read it clearly here. 2 steps, 3 steps. Find the radius, okay? And once you find the radius, build 2 equations for you to do simultaneous equation. One by using the formula of distance. Another one is by using the mathematical fact that 2 perpendicular lines have the product of their gradients negative 1. Okay, a very long one, but that's that. Okay, for center of curvature or circle of curvature, curvatures, radius of curvature, anyone, do you have any question that you are unsure of? And by the way, for number 3, I know that I asked you to try it on your own, but okay, let me snap a picture and share the solution on the chat box right now, because for number 3 it's quite long as well. Okay, is this correct? Question number 3. Yep. So again, it was a very long process, but the final answer was very simple. This is the very final answer. But in order to get this, there was a lot of simplifications involved. Okay, so that's that. Anyone, do you have any questions on what we have just learned today? That's the whole aim. We are done for today, okay? So do you have any questions? Okay, I'll take that as a no. Let me give you the QR code for your attendance. There you go. We have a few more, actually 4 more. So 38 are present. Let me check the participant list. Oh, there are 38 of us. Okay, including me, 39. So that's that, guys. Let me stop sharing the screen and let me stop recording.